Get that out of the way. So names and formulas of ionic compounds, you guys are pretty keen, so you write that down as soon as I put it up. That's excellent. And the first thing I'm going to write about is what we call the crossover method, all right? And you're going to find as you take chemistry that there's all kinds of sets of rules on how to do things. Step 1, step 2, step 3, et cetera, et cetera. And you know what? Sometimes it's good to write it down. I'm going to make you write this down. But I'm hoping after we do a bunch of examples and you get a chance to work on some practice problems, I'm hoping you never have to look back at this slide ever again. Because this is the type of skill that once you do it enough times, you're going to just do it. You're not even going to think about the rules anymore, ideally. So if we were to formalize this, first thing we want to do, write the symbols of the metal and the non-metal. Metal always comes first, non-metal second. I'm not sure, again, the origin of that, why that came about. It's been like that for many years. Even in the Lavoisier book, we're talking early to mid-1700s. You know, even in the Lavoisier years, they were always described as metal and then the non-metal, even with the "-ide ending. That existed back then. Who did that first? I have no idea. One way to think of it is the metals are on the left on the periodic table, the non-metals are on the right, put the metals on the left. That's not the way it was originated, right? But that's a way to remember it. Write the number value of the charge above the symbol. I typically even include the charge, right? I'll even write down a -1, but I know when I cross it over, I just ignore the negative, because we can't have negative atoms. Cross over the number values of the charges to the lower right-hand corner of each element. In other words, we cross them over to make them become subscripts. That number now designates how many atoms of that type are needed. Once you're finished that, write the chemical formula. We do not write subscripts for 1 in chemistry. If it's a 1, we don't write it. We assume it to be a 1. And if there's any common factors that we can cancel out, we do so. And you'll see when we do some examples. It's a very straightforward thing. Nothing to stress over. Now, it might have been a good thing. I could have actually started a clear white screen. I could have done this explanation in the recording. Maybe I'll do that in another time. But this is where it comes from, all right? And we don't want to have to draw this every time. We actually want to be very quick at it, very good at it. Because in the end, naming and formulas is the language of chemistry, all right? And when you get to higher level chemistry, if I'm the teacher of you, or when your professor or your teacher gives you a description of some chemicals with the official names, we want you to be able to write that formula down right away without even thinking, right? Just like someone who's fluent in French can just say all those words without even thinking, as opposed to myself. It should be entertaining on the French ski trip. I will struggle through every little word when I'm asked to speak French. It'll be entertaining. Anyway. Yeah, by the way, I'm chaperoning, one of the chaperones on the French ski trip. If you think that'll be entertaining, it will be entertaining. I'm just waiting for the slow writers. Don't look around, just keep writing. Are you done? Or did I embarrass you to like drop your pencil? That's it, I quit. Not taking this harassment. All right, so now examples, e.g., examples. Now, I've got a periodic table here on the screen that we're recording, but you know, you've got your periodic table, and the periodic table's up here at the front of the room if you don't have a copy of your own. And you'll notice I don't have those nice little charges written above, and here somebody has put the nice little charges above for you. But I would hope we don't need those little charges. I would hope we have the ability to remember +1, +2, +3, and then depending on whether we've got metal or non-metal, ±4, -3, -2, -1. Because remember, it's the charge of what the ion becomes when it gets its full outer shell. These guys are gainers, going to gain 3, 2, 1. These guys are losers. Metals are losers. All right, they're electron losers. All right, so very simple. If you've written down aluminum sulfide and you're ready to go, you write down aluminum. What's the charge on an aluminum ion? +3. You can just put 3. That's fine. I'm actually going to put +3. Now, in my rules, it said, don't write down the charges. They'll confuse you. They won't confuse you. Like, don't write down the sign. It said write down the number, just 3. But I do like the sign. I like the sign to remind us that that's a positive ion. It's a metal ion. So I like putting the sign. Sulfide. What charge does sulfide become when it gets its full outer shell? -2. Again, I like to write -2. All right? But you know what? In the next couple of examples, if you're starting to get the hang of it, you don't have to write any of this down. You can put it there in your mind, cross it over. Like, how tough is that to do? So in the end, I don't want to see all these steps. In the end, I want you to see the name, and I want you to write the formula. All right? So in the end, you're going to be going straight to the formula. So crossing it over, we'll use some color here. There we go. We're putting that there and that there. Again, you're not going to write that down every time we do this. That would be painful. And so what do we have? We have Al2S3. Just like the selenium. That's why I picked selenium instead of sulfur, because I knew what this example was. And that's it. Are there any common factors there? No, I can't divide anything out. That's the formula for aluminum sulfide. Beryllium oxide. I think we can already make the jump. I think we can already make the jump where we don't have to write the charges down up above, because in our mind, we'll just drop it down right away. Everybody kind of see what I'm saying? So write down beryllium, Be, oxide, write the O, find the charge for beryllium, don't write it down, think it, and then cross it over. What am I putting right here by the O? What number am I putting here by the O? Yeah, at the back there? 2. 2. Think of the charge of oxygen. Don't tell it. Think it. Thinking it? All right. Cross it over. What am I putting right here? What am I putting? 2. Excellent. 2. Beautiful. No need to write it down up there. We can cross that over quickly. In this case, we do have a common factor, so we must get rid of the common factor. We divide off by 2 for both of them. So I will make a mark here. We're gonna divide both of these off by 2. In other words, they're canceling out. They're canceling down to 1. They're becoming 1. All right? Again, you don't need to write that step. BeO, because each Be will trade the 2 for the O. All right? Again, I'm hoping when you get to, practice enough of them, in your mind you cross over the 2, you look at the O, you see the 2, you cross it over, you cancel it out in your mind, you leave it as BeO. All right? So that's where we want you to be eventually as, fluent chemists. All right. I'm not going to write anything down this time. You write down the metal. You write down the non-metal. Try to cross it over in your mind. Cancel away in your mind if you can pull it up. If you can't, draw the arrows. Again, do it in pencil. And then in the end, I want someone to tell me what to write down here for the formula. Patience. We're going to let the brains, their gears are turning. I can hear them. They're a little squeaky. I had most of your names. Now I'm struggling for some reason. Don't know why. Right. Okay. I'm going to pick on someone. I'm going to pick on Sammy. You got an answer, Sammy? That means she's got an answer, but she's not sure about the answer. That's all right, not a problem. Tell me what you've got for the formula. Ca, sorry? 3? No, there's not a 3. Let's take a look at the fluorine. What charge does fluorine become when it gets its full outer shell? Somebody help her out, yep. -1. It's going to gain 1 electron. It's going to become -1, which means a 1 is going to cross over to there. Okay? Ca, and let's finish it off for who's got it? Yes, oh, check a name. I got it. Kayla. Yeah, CaF2. 2 from the Ca, the 1 from the F. Okay? All right? And one more example. It's right there, by the way, if you're wondering where gallium is. It's right there. Think of the charges, cross them over, do anything you need to do. Mackenzie is straining his face, he's raising his arm, he's thinking. You're going to give me an answer to this?
I think so.
All right, what do you got?
Is it G-A...
Oops, wait a minute, my pen's not working. I'm writing it. G-A?
3N?
So the 3 is coming from the nitrogen? Is that what you're saying?
Yeah.
Yeah, okay. I'm going to write that down. And what's the charge on the Ga?
Oh, yeah, so yeah, plus 3, right?
It's +3, which means its 3 is going to go down, right? And what can I do in the end? Yeah, Kendall? Yeah, they'll cancel away the 3's. So this is just GAN. Okay? All right? Now at this point, I'm going to give you about 5 minutes. If you've printed it out, I have a big long sheet of example problems, and if you've got that sheet, that's great. But if you didn't print it out, I'm going to put it up on the screen, and you can do them there. Now, unfortunately, I do this in an opposite order to which the sheet was made, and also the sheet's a little ugly because I tried to fix it so that it would look better on Google, but it doesn't look that great. And this is really just a practice sheet. Let me open it up here. So there's all these extra lines, etc., and you'll notice part 1 here on binary ionic compounds, this first section, it deals with coming up with the names. So I'm going to put this second section up right in here. I'm going to zoom in a little bit. Let's zoom in here. I'm going to zoom into there. I'm going to slide that down. I'm going to move that over right there. So those 1 to 10, for about 5 minutes, I'm going to let you practice those. All right? So at this point, I'm going to pause my recorder as you're working. Okay. So potassium oxide. This time I just want. Oh, I don't have my microphone on. Not much of a recording if I don't put a microphone on, do it. This time I just want the formulas. Don't tell me what the crossover or this and that. Just tell me what the formula is. So what do we got? Hands up, please. Don't fight over it, please. Really, no, really, one at a time, please. Allison, what do you got? Oh my goodness! And my recording thing is not going to allow me to write on this. Really? Really? Nothing at all? Not even close? Oh, there it goes. Now I've made a mess of it. Scribble, scribble. K2O. I like it. Okay, number 2, aluminum sulfide. Yeah, Mackenzie?
Oh, wait.
That's all right.
AL2S.
Al2S 3. We got to cross over the aluminum's charge. Don't forget the second part of it.
Yeah, I think.
All right. What do we have for strontium chloride? Kayla, what do you got? SRCl2. Is strontium in group 2? It is. Correct. I was just checking because I don't have them memorized. Yep, strontium's in group 2. Nice job. Sodium sulfide. Sodium sulfide. Megan up front. Na2S. I like it. Silver phosphide. Silver phosphide. This was a tricky one. Kendall, what do you got? Ag3P. Very nice. Again, silver is not in one of our main groups, but we can get its charge off of the table. Silver is +1. Calcium bromide. Calcium bromide. I got to get some names. I got to pick on it. Jordan, what do you got? CaBr2, crossed it over very nicely. Lithium nitride. Jocelyn, right? Jocelyn? Li3N. Nice. Beryllium oxide. Shayna. BeO. Didn't I do that as an example? I think I did. Anyway. Magnesium fluoride. Trent. MgF2. I like it. And potassium chloride. Okay, Kayla, what do you got? KCl. All right, nicely done. Okay? You must know the charges. If you know the charges, it's an easy job. Okay? So I got to do a lot of stuff here. Let's get rid of the ink. Clear the ink. Let's head back to the PowerPoint. And let's move on. Formula to names. You know what, folks? Goodness gracious. Let's bring this whole thing up here. Yeah, we'll bring that whole thing up. Again, you know, we're encouraged as teachers to write down all the steps so that all the kids can go back and make sure they know it. But formula to name is easy when it comes to ionic compounds. All right. Oh, by the way, on the handout, and I don't have this in this note because we don't want to concern you guys with it, but in grade 11, I don't just call them naming ionic compounds. I say naming binary ionic compounds. All right? These are all examples of binary ionic compounds. Why do you think they're binary? What do you think binary means? What do I mean by binary ionic compounds? Marissa, what do you got? There's two elements in there. Now, there might be more than one atom of those elements, but it's only made up of two elements. And I'm going to convince you next year, hopefully when you take my chemistry, that the naming system that we use is binary. That means when you write the name of an ionic compound, there is always only two parts. Even on Monday, when I introduce you to the polyatomic ions, those bigger chunks, right, with more atoms in it, the name will always only have two pieces to it. The name will always have the name of the positive piece, the positive ion, in this case the metal, and the name of the negative piece, the negative ion. So the name is always only made up of the two ions that are in it. Hence the naming system is binary in nature. So, write the metal first, write the non-metal second. We've already talked about naming the ions. The positive ones don't have their name change, right? So you can have a calcium atom or a calcium ion. In this case, it's a calcium ion because it's already traded its electrons. And the negative ones, they get an "ide" ending. What's the name of this particular compound that we have as our first example? What's the name? Yep, Megan? Yeah, it's that simple. Calcium nitride. It doesn't matter how many calciums or how many nitrogens I have, it's just calcium nitride. Now, when we talk about molecular substances, which are different than these, things like things like CO2. You may already know what the name of CO2 is. What's the name of that molecule? What's the name of that molecule? Any ideas? Mackenzie, what do you got? No, that's not air. Nope. It's part of air, but it is not air. Nope. Anybody know the name of that stuff? Yeah, very good. Carbon dioxide, right? Carbon dioxide produced by respiration and combustion, all that type of stuff, right? Now, that's a different naming system than this, because I put the di in front of it to tell us that we've got two oxygens. But notice here, I don't use any of that di, tri, blah, 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 blah stuff. So when you have an ionic compound, which is made up of a metal ion and a non-metal ion, you don't put those fancy things in it. Calcium nitride, done, easy. This is a molecular substance because there's no metals in it. We'll learn that down the road in a couple of days. When there's no metals in it, it's not ionic, it's a molecular substance. And then we need a slightly different naming system. But the ionic naming system is easy. Don't worry about the numbers, don't worry about anything. Name the front chunk, name the back chunk, put it down, you're done. Okay? It's the easiest naming system that you can think of. So here we've got again, EG, put some examples here. Ooh, ah. And yeah, I'm slowing you down. Some of you might even have that sheet there, part one. You've probably done it. You could probably fly through it in the time I go through these examples, which is good. What is this going to be called? Yeah, Kayla? Yeah, lithium sulfide. And my pen isn't going to work. Lithium sulfide. All right? One more example, and then you can then work on that sheet, the top part of the sheet, which some of you might be already done. As I'm talking, cheating away, filling in the answers. Nice. What's the name of this one? Yeah, Allison? Aluminum chloride. Yep. Aluminum chloride. Look at all the M's and the N's and the U's in there. That's chaos. You've got to be very careful when writing that down. All right. Now you can finish off that top part of that first section. Okay? I'm going to switch back to here. I'm going to put the pause on the recording. So we'll roll up to here. So you can then work on that one. And as I suspect here, many of you are later. If not, I'll put the solutions there. Okay, so we'll start recording again. Here we go. And so I'll take the name of number one. Yep. Yes. Potassium bromide. My writing is fast. Put an E on the end of that. How about the second one? Sammy. Yeah, very good. Zinc iodide. Zinc iodide. And oops. And you might think that we're just making up funny sounding things, but all of these things can be made. We can make all of these compounds. They actually exist. Next one, Kayla. Yep. Lithium sulfide. Oops. Sulfide. Next. Mackenzie. Yep. Aluminum nitride. Next. Yep. Lithium bromide. Yep. Lithium bromide. Lithium bromide. Up top there, Kendall. Calcium oxide. Next, Trent. Beryllium fluoride for spelling purposes. And Kayla? Yep. Zinc chloride. Yep. So, whoops, there's an O in there. Sodium sulfide. Whoops, I'm really struggling with the IDE ending. What do we got there, the last one? Sammy, what do you got? Magnesium phosphide. Awesome. Okay, like I said, easy naming system. No need to worry about the numbers. We now know where the numbers come from. They come from the charges. But naming is easy. Name the front chunk, name the back chunk, and the back end is IDE. when it's binary. It'll change a little bit on Monday when we do the polyatomic ones. They're going to have some new endings, but you'll be fine. Okay, so let's, what do we got to do here? Eventually I got to get rid of the writing, clear the ink. Let's go back to the PowerPoint. Nope, that's not what I want. Oops, not that one. That one. Okay, now, multivalent metals. What a great term. Multivalent. All of the examples I've given you up to this point are examples of elements that have only one possible charge. That's a lie. I lied to you. But let's stop writing just for a second, and then I'm gonna get you. I'm gonna tell you why I lied. All right. Up to this point, I've only given you ones that are out of the nice main group, or something like zinc, or something like silver that has only one charge. But if you look on your periodic tables, you'll notice that chlorine has all kinds of different possible charges. If you look at the bottom of the box. Same with bromine, same with all these guys at the bottom. And these are pretty complicated molecular structures that have these funny charges. We're not dealing with that in this course. So I need you to assume that if it's in this group, -1 is the charge, no matter what it says in that bromine box. -1, -2, -3, plus or -4, +3, right? For zinc, it's +2. For silver, it's +1. But what we want to look at now are some very important transition metals that we can't draw Lewis diagrams for, and that you're not going to be able to explain why they have two charges until you get to grade 12. Then we're going to tell you why this is the case. But right now, you don't have to worry about it. But it turns out that things like copper and nickel and cobalt and iron, manganese has all kinds of them, they have more than one charge, all right? So we're going to talk about some of these, and I'm going to need you to know these charges, but you get to use your periodic table, so as long as you know where to find the charges, you can get them, okay? So copper has two possible charges. You can write down now again, multivalent metals. Some metals have more than one possible ionic charge. I stopped you from writing, so now you may continue to write again. And write down copper and put down the two Cus, and then wait for me. And now let's go to the periodic table and tell me the two forms of copper. You know what? We talked about copper forever in our experiment. You might remember what the two possible forms were, Jocelyn. 1 and 2. And if you remember that, that's awesome. And if you go to the periodic tables, you'll see there's a 1 and a 2, right? So there's two ways of getting it. Memorize it or go to the table. So copper can be copper +1, or it can be copper +2. And those are two little numbers up top to show the charge, like if we were going to cross it over, right? Now, we need to be able to differentiate between these two types of copper. So we add a number, we add a Roman numeral to differentiate between which type of copper ion we're talking about. So to name this ion, we call this copper, brackets, Roman numeral 1. Copper 1. This one is called copper 2. So how do we fix it when there's more than one? We simply indicate with brackets and a Roman numeral what charge is on that ion. So now we could have something like copper 1 sulfide. That tells us we're using the copper 1 version, and we know sulfide's -2. We can cross over. We can do what we need to do. Go ahead. Complete iron and lead. Use your periodic table if you have it. If you can't see it, you might have to squint to spot the charges up here on this one. See if you can finish it down for those. Nope. Yeah, iron 2 and iron 3. Yep. It describes the charge. We okay with our Roman numerals? Because you're going to need a 4. Remember how to do the 4? One before 5? All right, good. 1 before 5. It's IV, right? Are there any 5s? Not that we're going to use, but do we have any 5s? There might be, but we don't have to worry about it. We're not going to worry about it. Yep. 3 I's. Yep. You can put the little capital I if you want, but you know what I mean? Like an I that looks like a Roman numeral I. That's good enough for me. That's the way it's commonly written in textbooks, et cetera, et cetera. So I'm not even going to write these charges down. Iron. What are my options for iron? Yeah, Shane, what do you got, Shane? 2 and 3. All right, one quick joke.
Okay. You want this one?
Yeah, okay, I'll do this one. Am I doing this one? Okay. Why did the football coach go to the bank? Because he wanted his quarterback. Excellent. Thank you. What are my lead options here? Lead and lead. What are my options here? Sammy? Yeah, very good. Lead 2 and lead 4. All right? Okay? Now, I'm not going to teach you. There's another way to name these. It's called the classical method. This method is relatively new, probably since about 1930. Before that, they used Latin in order to describe these things. And they used endings that would indicate whether you use the high charge or the low charge. And you'll learn this next year. I teach it in grade 11. This is sometimes called cuprous and cupric. And this is ferrous and ferric. And this is plumbus and plumbic. So it uses the Latin names. You're not going to worry about that this year, but you'll see that next year. It's kind of neat. It's called the classical naming system. Manganese. Which 2 charges do we use for manganese? There's a million of them. Don't bother with manganese. Don't even bother with it. Because manganese has 7, 6, 4, 2, 3. Don't even bother with it. I didn't make this note. And to be honest, I didn't look this far when I should have looked over my notes before. Yeah, we're doing tin. For sure we're doing tin. Is there something we can put in there other than that we might see? Well, you know what? I don't need to do any more really examples because you could just use them, right? Notice gold. Gold has 2 options, right? So you'd have gold 1 and gold 3. For manganese, it depends on what charge you use. Manganese, like I said, has 7, 6, 4, 2, 3. So there's not just 2, but you could use whichever one that you're told. So if I told you to use manganese 7, then I'd write manganese with 7, right? It'd be manganese 7. That's what the charge would be, all right? So even though I've got only 2 examples, I really should have like 5 examples for manganese. What are my examples for tin? Yeah, Mackenzie? 2 and 4. So it's tin 2 and tin 4. Excellent. So, yep. Oh, that's the grade 12 thing. I can't even begin to tell you the reason.
How do we know which ones are the univalent or multivalent?
Okay, that's a good question. I can tell you that. You're going to assume, because you'll notice here I got tin 2 and tin 4, right? And I told you if it was in the main group, assume it was 4, right? That's a good question. In the name, all right, if I give you a univalent one, there is no brackets nor Roman numerals. You see what I'm saying? So in the name, if I give you brackets and Roman numerals, it's got more than one charge. Going back the other way is a little trickier, and I'm going to show you how you determine that in a minute. Okay? Going back from the formula to the name is a little bit of a trick. Okay? And I'm going to show you in a second. All right? And the reason why they have more than one charge, very complicated explanation about subshells and all kinds of crazy things. Sorry? Bromine can have all kinds of them. Very complex reason why. I'm not even going to begin to explain. You need grade 12. Yep. You need patience. Yep. Univalent means it's only got one charge. All of the ones we did first are univalent. Uni meaning one. Okay? And multivalent means they can have more than one. Yep.
But we were using chlorine and bromine, and they've got one.
Yes, and I'm telling you in this course, just treat it as -1.
Okay.
Just treat it as -1. Because you'll learn in grade 12 where all those other charges come from. And 2 years from now, 2 years? 2 years from now, when I do this, I'll say, remember, Marissa? Hopefully I'll remember. Now I can tell you why that is. All right? Okay. All right. Formulas. Formulas are easy. Cross it over. And this is actually easier than if it's one charge, because I'm actually telling you the charge right in the name. No need to even go to the periodic table, because the iron, the Fe, is going to be +2, because that's the charge. The only thing you have to check is the chloride. What's the charge on the chloride? -1. So what's the formula of this going to be? Megan? FeCl2. So in essence, getting the formula for a multivalent is even easier because we tell you what the charge is. No even need to go looking for it. It's there. That's the tricky part. Getting the name going in reverse, we've got to do some thinking. We've got to think about which one it can be. Do you go backwards? We can. There's 2 ways that I teach on doing this. What is my time anyway? We're doing good. Formula for this. What do you got? Yep, Galen? PB204 is a good start, but we now have the last step to do. There's a common factor in that. Bring it down. So what's going to be? 1 and 2. So this is then going to become PbO2. Okay? Tin 2 sulfide. Yeah, Mackenzie? Yeah, nice. SNS. SNS. All right? Okay? Now I don't have a page for this. There are textbook questions that the textbook likes to integrate everything together, whether it's univalent and multivalent. They're tricky. They like to stir it up a little bit. So we're going to use some textbook questions in a moment, but we're now going to go the other way. Oh, what's the matter? What didn't we like? 2 and 2? 2 and 2. Are we catching what I'm saying? What I mean by 2 and 2? Good. I like teaching fast. You guys, I think, are catching what I'm pitching. The SN was 2 and the S was 2, and they canceled out and they became 1 and 1. All right. Now, how do you get the name? I do this 2 ways, and when I write it down, I have a certain plan, okay? So let me show you what my plan is. When I get one of these, this is what I go through in my mind. I see the iron, and I remember that iron has 2 options. Or I go to iron, and I see that iron has 2 options. So I write down iron, I put brackets, but I don't put anything in it, because that's what I'm going to think about. And it's ionic, so what's the end of this going to be called? Iodide. Iodide. In other words, I get the stuff out of the way that I already know how to do. Okay? Now, 2 ways in which you can do this. You can do this with something we would call the reverse crossover. Bring them back to their original position. Where did this 3 start out as when we were crossing over? Where did the 3 start out as? Kayla? It started out up here as iron, 3. And this 1 that we don't write down, where did it start out as? the iodide. Now, we already know that the iodide is -1. So that's fine. We don't care about that. But what type of iron must this have been in order to get that formula? Kayla? 3. It's got to be the 3, because the 3 went up there. So this is iron 3. Now, sometimes you get caught doing that reverse crossover, especially if something has canceled away. If we've canceled away something in the formula, then we get the wrong number up there. So the second way that I do this is, in my mind, very quickly, I look at iron, and I see that it's 2 and 3. And I quickly come up with the formula for both of them. If it was iron 2, what would the formula of this thing been? If it had an iron 2, instead of an iron 3, what would the formula have been, Megan? And is that FeI2? No. If it was iron 3, what would the formula have been? FeI3. It's got to be the 3. So I quickly do both formulas in my head. And I say, oh, that had to be iron 3. That's iron 3. Okay? Let's look at this one. Well, let's do this one using that method. What are my options for copper? Actually, I'm going to write down first, like I said, copper, blank, bromide. I think you're all there with me. So what are the 2 options for copper? Go to your table. If you don't have a table, the book actually has the 2 options in it. Sorry, what are they? 1 and 2. Think about the possible formulas if it was copper 1 or copper 2. And then just tell me, which one does this have to be? Kendall? Yeah, it's copper 1. It's copper 1. It has to be. That's the formula. Sorry? Because what's the charge for bromine? The main group. It's in group 17. Searching for the bromine. Oh. It's going to take you a long time to get formulas that way. What's the charge? -1. So if it was copper 1, or if it was copper 2, okay, which one does it have to be? It's got to be copper 1. That's what it is. And you know what? I've taught that reverse thing for years, but I like this method better. It's quicker. It's easier. Let's look at this. PbO2, because this is where we get into trouble. If I reverse it, a 2 goes up on the lead, but a 1 goes up on the 2, right? But oxygen doesn't have a charge of 1. What's the charge of oxygen? 6 outer electrons. Oh. That's okay. You're thinking it through. It's just her thoughts come out of her mouth. Which means something had to have been canceled away. So you get in trouble just doing the reverse charge. So let's think it through. What are my options for lead? Yep. 2 and 4. Oxygen is 2. So I've got something like this. I've got lead 2, oxygen 2, or I've got lead 4, oxygen 2. Which one results in the proper formula that you see? Yep. Yeah. It's lead 4. Yeah. Now we don't write oxygen 2, we write oxide. Right? So lead 4 oxide is what it is. Lead 4 oxide. Lead 4 oxide. Okay? Fun? Because if we've canceled something away, the reverse gets you. It means you've got to bring the common factor back. The 2's got to come back. Or just go through them both in your head if you're good at it. I'm not even going to guide this one for you. Copper. It's got 2 options. It's with a sulfur. Whatever method you want to use in your brain to figure out what that is, I'm going to put here a copper. I'm going to put the blank in there. I'm going to put a sulfide. And now you just got to use your brain. And, oh, everybody's keen. This is exciting. Kendall, you had your hand up first. Yeah, awesome. Copper 2. Nice. Because the 2's had to cancel away. Okay? All right? And there are some textbook questions. And the textbook questions will be a mix. All right? The textbook questions will be a mix. Some of them only one charge, some of them more than one. It is wrong to put brackets and a Roman numeral for something that has only one charge. You see what I mean? The naming system is minimalistic. If it only has one possible charge, like sodium, it is wrong to say sodium 1 chloride. It's too much information. There's no need for the 1 because it only has one option. But if there's more than one charge, like in a copper, you can say copper 1 chloride. Yep.
So do you say that for just the ones that we listed here, copper, iron, lead, and tin, or do we do it for?
Don't do it for the main group ones. Don't do it for bromine. Don't do it for iodine. Don't do it for those guys. But yeah, tin down here, yes. Yep. That's exciting. All right, I'm going to pause this for a minute, and then I'm going to try to clarify this, or not pause it. I'm going to stop the recording because we don't need to record all this.